Alright class, we're going to be continuing on with section 3 of chapter 7. This is where we're going to start seeing a little bit interesting exponents, right? We've been dealing with positives, and now, or just the other day, we were dealing with negative exponents. And so today we're going to be dealing with rational exponents, meaning fractions. So what do we do when we have a fraction as our exponent? So it's all the same rules for multiplication. If they have the same base, then you add them. If it's a power to the power, then you multiply them, right? So if you look here at this example, you have b raised to the 1/2 all raised to the 2. Now what they did, since this whole thing is squared, they broke it down to b raised to the 1/2 times b raised to the 1/2, and then the rule is 1/2 plus 1/2, which is 1. Or you could have done multiply these two, 1/2 times 2, and 1/2 times 2 we know is just 1. So b to the first power, or just b. And so just because we're dealing with fractions doesn't mean anything really is changing. Now, one of the key things, the first key thing today is that when we have a fraction, especially with 1/2, this actually is something that we call a square root. I'm sure many of us have seen the radical sign. This right here is called a radical sign. It looks like a division sign, but that's what we call a radical. So you will be seeing that a little bit more as we finish off this school year. So b raised to the 1/2 is the same thing as the square root of b. So that's the first key concept that we're going to be focusing on today. B raised to the 1/2 is the same thing as square root of b. So if you look at this first example here, 16 raised to the 1/2 is the same thing as square root of 16, and hopefully we know that the square root of 16 is 4. Same thing with this example, 38 raised to the 1/2 is the same thing as square root of 38. There actually is no square root of 38, so you just leave it there. If you scroll down, and maybe I'll do a few examples, and then I'll kind of let you do the last 3 examples. So this first example, we have 25 raised to the 1/2 power. The directions say write each expression in radical form, or write each radical in exponential form. So 25 raised to the 1/2, that's the same thing as square root of 25. And if you can evaluate it, go ahead and evaluate it. Square root of 25 is 5. For letter B, the square root of 18, so this one we have to change to 18 raised to the 1/2 power, and then that's it. Now here, letter C is actually kind of tricky because it's 5x to the 1/2, and we talked about in class, what does the exponent touch? The exponent only touches the x, it doesn't touch the 5 at all. So if you want to change it to radical form, only the x is under the radical, since x is the only one being touched by the exponent. And so this right here is my final answer, 5 square root of x. Why don't you try D, E, and F on your own and see if you can get those. So the first one for D, we got this whole group is under the radical sign, so that means I need to make a group to be raised to the 1/2 power. For letter E, a to the 1/2 is the same thing as square root of a. And then for letter F, again we see this whole group is being raised to the 1/2 power, which means this whole group is going to be under the radical sign, like that. If you have questions, we'll kind of go through it tomorrow. I know it could be a little bit confusing now that we have such different properties that we may have never seen before. Alright? So if you scroll down, we're going to get to the second concept before we end this video. Now if we extend this idea of b raised to the 1/2 is the same thing as the square root of b, then what if we have something like b raised to the 1/3 power? How does that transfer? So what Actually, this next concept is, what if you have an nth root? An nth root. Meaning if you have a to the n power equals b, then the nth root of b is equal to a. So what that means is b to the 1/3 power is the same thing as the cube root of b. So what you do, the same radical sign, and inside the little v, I guess, the little dip, is the number 3. In the same way, b to the 1/4 power is the same thing as the 4th root of b. And so for letter A in this second example, we have the cube root of 27. Now you have to think about, okay, there's some number raised to the 3rd power that's equal to 27. And that number happens to be, in this box, happens to be 3. So 3 times 3 is 9, times another 3 is 3. So the cube root of 27 is 3. For letter B, you have the 5th root of 32, meaning there's some number being multiplied by itself 5 times to get an answer of 32. Take a minute to try and think of what that would be. That number would be 2. This box would be 2. And the last one, maybe you could try on your own. What is a number raised to the 4th power to get an answer of 16? That also happens to be 2. 2 to the 4th power. 2 times 2 times 2 times 2 is equal to 16. So, you know, if you don't know these answers, then just by memorizing and just by repeating a lot of these things, a lot of these smaller numbers, will kind of get used to it. Okay, so we'll practice this a lot more in the upcoming day, and we'll finish the back page of the notes. If you want to go ahead and try the back page of the notes on your own based on the examples and based on the concepts that they write out, then you can try it, but I will clarify things tomorrow when you get to class.